For in this video, we're going to talk about suggested homework problems from 5.9. We just have a few problems to talk about, but before we can get to them, we need to talk about some differentiation rules that we have for hyperbolic trig functions and what the hyperbolic trig functions are. So hyperbolic trig functions are defined this way. Sinh x is e to the x minus e to the negative x over 2, and cosh x is e to the x plus e to the negative x over 2. We saw these functions earlier in our differentiation integration of exponential functions, and I said that we would get back to defining what those special functions were that they were showing us. This is an odd function, and this is an even function, just like sine is odd and cosine is even. Hyperbolic tangent, I won't define it in terms of e, but it's hyperbolic sine divided by hyperbolic cosine. And then you have hyperbolic secant is the reciprocal of hyperbolic sine. Hyperbolic cosecant is the reciprocal of hyperbolic sine. And hyperbolic cotangent is the reciprocal of hyperbolic tangent, but it's also hyperbolic cosine over hyperbolic sine. So won't get into any of the Pythagorean identities for hyperbolic trig functions. They do some different things than they do in regular trig functions, and I'll let your teacher talk about that when you get to those. But this is what we'll need to know for these problems. Now let's talk about the derivatives. So the only two derivatives that you really need to know, because we can write everything in terms of sinh and cosh, is that the derivative of sinh is cosh, and we'll use the chain rule here to define these just in case we don't have a simple x. The derivative of cosh is sinh, and so again, using the chain rule here, don't forget to multiply by the derivative of the inner function. Notice that we don't have a negative derivative when we have a cofunction here in hyperbolic trig functions. That's different than we expected. Normally, sinh and cosh, or sine and cosine, were cofunctions, and we would have expected to have a opposite sign for the derivative. We don't have that here. So that's the main thing to notice. Let's go ahead and let's actually establish that while we're at it here. Derivative with respect to x of e to the x minus e to the negative x over 2. We might have done this one earlier in homework, but this is derivative with respect to x of e to the x minus derivative with respect to x of e to the negative x. So that is 1/2 of e to the x minus a negative is plus e to the negative x. It's e to the x plus e to the negative x over 2. So this is cosh x. This was derivative with respect to x of sinh x, derivative with respect to x of cosh x is derivative with respect to x of e to the x plus e to the negative x over 2 is 1/2 derivative with respect to x of e to the x plus e to the negative x. So this is 1/2. and then derivative of e to the x is e to the x, and derivative of e to the negative x is negative e to the negative x. So this is e to the x minus e to the negative x over 2, which is sinh x. So the derivative of sinh is cosh, the derivative of cosh is sinh. And if we use the chain rule, then we use u substitution, and don't forget to multiply by the derivative of the inner function. All right, that was a lot of preliminary, but we've just got 4 problems here. So if f of x is equal to sinh 9x, then u is 9x and u prime is 9. So f of x is equal to sinh u, f prime of x is equal to cosh u times u prime. So f prime of x is equal to cosh 9x times 9, or 9 cosh 9x. 26. F of x is equal to cosh 8x plus 1 is cosh u, or u is equal to 8x plus 1, and u prime is equal to 8. So f prime of x is equal to sinh u times u prime. F prime of x is equal to sinh 8x plus 1 times 8. F prime of x is 8 sinh 8x plus 1. Let's clear the board. Look at number 29. 29 says f of x is equal to ln of sinh x. U is equal to sinh x. U prime is cosh x. F of x is equal to ln of u. So f prime of x is equal to 1 over u times u prime, or u prime over u. F prime of x is equal to cosh x over sinh x, and we talked about that quotient identity earlier, that is hyperbolic cotangent of x. Let's look at 31. H of t is equal to t over 6 sinh of negative 3t. So this is u times v, or u is equal to t over 6, and v is equal to sinh of negative 3t. U prime is 1/6. V prime is cosh of negative 3t times negative 3. So h prime of t is u prime v plus v prime u. H prime of t is 1/6 sinh negative 3t plus negative 3t over 6 cosh negative 3t, and h prime of t is 1/6 sinh negative 3t minus 1/2 t, or negative t over 2 cosh of negative 3t. I'm writing t over 2 because they wrote t over 6 there. That's it for how the book wants you to answer, because they want you to leave this argument the same as what it started off with. So don't use the even or odd identities that we talked about. Just leave it like that. All right, that's it for this video, and we'll talk more about, let's see, we'll come back and we'll talk about 7.1 next time, which will be our last section of homework for our Calculus 1 topics. So see you for the next video.